This is Mr. Max, and I am doing paper 2 of the Namibia Senior Secondary Certificate Ordinary Level Mathematics. This was the paper that was 3 hours long, 2024 paper. Okay, right. Obviously, what you always have to look is what are the additional materials that you will need. Since he's indicated that you need geometrical instruments, well, probably you need to have a protractor, a ruler, you need to have a pair of compasses, a pencil ready, and all that stuff. This one, non-programmable calculator, is always there. When they say something is optional, it always indicates that you don't really need it. Okay, this is maybe in places or cases where you are dealing with questions on transformations. It's either some shape has to be rotated and you need to find the center of rotation and stuff like that. Okay, but it's optional, which means it's not something literally that you need to use. And another thing, it's not a lot of marks, maybe it's a 1 or 2 mark question, so you cannot be bogged down more than 2 minutes trying to find the center of rotation when it's an optional thing. Anyway, the instructions, you always have to make sure that you read your instructions. I believe the most important one here, all of them are important, but this one that deals with the degree of accuracy. So for this particular paper, if the degree of accuracy is not specified, so in the question they don't say give your answer to this and to that, if they don't say that in the question, then, and if the answer is not exact, remember an answer that is exact, even if it's a decimal, if the decimal terminates, if it stops, it's an exact answer. But when an answer continues, like a recurring or continues, this is where you now give your answer to 3 significant figures. When you deal with angle sizes, for this particular level, you give your answer in degrees to 1 decimal place. If there is values of pi, any calculation that involves pi, it means probably the area of a circle, or you have got some any shape, geometrical shape that has circular or that is circular by nature, where you need to find the surface area or stuff like that, or the volume, then you are either going to use your calculator value of pi, or you can use 3.142, which is a pretty much good estimate of what the value of pi is, considering pi is an irrational number. So anything that you do to this pi, when you multiply any operation or so, you will always have to give your answer to the degree of accuracy specified, because there's an irrational number, the answer doesn't stop. Anyway, let's just get straight down to it without wasting time. So question 1 consists of a series of numbers, and from that list of these numbers above, you need to write an irrational number. Again, an irrational number is a number that cannot be written as a fraction. Now the square root of 5 is a number that continues, it never stops. All of these numbers besides that can be written as a fraction. A whole number can be over 1, negative 1 over 1. They can all be written as fractions. Now a square number, this is just recalling. There is nothing here to give yourselves a headache. Square number, that is obviously 13 times 13. That is giving you 169, which is 169 in the list. The smallest number, now think of the number that is furthest away from 0 to the left or down, depending how your number line is, if you have to need that visual. Obviously, negative 7 will be the smallest number, okay? Take note, negative 1 is obviously closer to 0, so negative 7 will be the smallest number in that arrangement. So these are all sort of very straightforward questions that just carry 1 mark and so on. You will see that I will be talking about the B mark, that is an independent mark. So when I do get to that, I'll explain it. Given question 2, that you are given 12 as 2 squared times 3, 100 as 2 squared times 5 squared, they want you to find the highest common factor of 12 and 100. Now, finding the highest common factor, you have to look at what is common here that is also common there, right? As you can see, it's 2 squared. It has times 3 times 5 squared. They are not common to both of them. So the answer would be 4, which is what 2 squared is. The lowest common multiple, now when you find, so that was the highest common factor, the lowest common multiple, you will write down what is common, which is the 2 squared. In the 2 squared, you write it down once. That is common, like what you did there. But you need more. What is it that you're going to write? Now you will be writing the other things that are outstanding. That times 3, and obviously this times 5 squared. Now you can punch this in, all right, with your calculator. No need for you to struggle. This is a 1-mark question, all right. So this is going to be 25 times 4, that's 100. 100 times 3, obviously this answer here is 300. Without using a calculator. Now, of course, this is a calculator based paper. So when you're solving this, it means we need to see a little bit of method, okay? So your method should either be you writing this as a fraction with lowest common denominator, okay? That denominator can be what is the LCD, or the lowest common multiple, or the lowest common denominator of 2 and 8. So obviously it is 8. And then if you express a half in terms of 8, a half is going to be 4 eighths, and 7 eighths remain. So it's important that you know that we are only adding the numerators, and once we do that, then obviously we are going to get our answer, which is 11 eighths. But you can simplify this further, okay, because they ask you specifically here that your answer should be a mixed number. Now clearly this is an improper fraction and it's not a mixed number, and a mixed number would be some whole with a fractional part, so 8 goes into 11, so that is 1s, and 3 is left, and you put that 3 over 8. So this is the solution that is required. So if you were to go straight on your calculator, for example, so say grab my calculator, and you were just to say, okay, I have got a half, all right, plus you say what, 7 eighths, and you just write this answer down. Of course, that is 11 over 8. You press shift and you press the SD, search to decimal button, and you get 1 over 3. As a way to check, you can write that down, but we need to see this method. Now, if we are marking this, we are not marking the answer, okay? We need to see the method. Anything that is close to, okay, even with a common denominator, it doesn't have to be 8, as long as it simplifies to that. So in this particular case, as examiners, we are going to say there needs to be a method mark, and then we give them mark for accuracy. We cannot give you an accuracy mark if there is no method. So if the method is 0, then everything is 0. Hence, this is very important that you show these steps for this particular question and all questions that carry more than 1 mark, because there is always a method involved. Next, question 4. Prince buys a television on sale for 924. That is the he bought that for that price. And then this 924 represents a reduction of 12% on the original price. So what does it mean? Well, it means that the original price that we are calculating should be higher, slightly higher than 924. Another thing that we don't know what is, because this is sale. He bought this TV, but this is what you have here. This is the selling price. So he bought the TV, but we don't know how much he bought the TV for. So cost price is missing. Once cost price is missing, the original amount of something, if it's not there, you should immediately know you are dealing with a reverse percentage scenario. Now, another step perhaps that you can use, you can look at saying this 924, okay, 924 out of something represents a 12% reduction. So let's suppose 100% of what the original TV was that we don't know. Because it's a reduction, we're going to say minus 12%. So this is 88%. So what does it mean? This 924 represents 924 over something. This something is the original price, is like 88%. That is what you do. Of course, you will see where the reverse percentage is coming from. So if we were to apply the cross multiplication, you are going to have, and just to, because now it's equivalent fraction, okay, you're going to have 88x is equal to 100 times 924. Now I'm not going to multiply out that, what is 924 times 100. I want to show you where the concept of reverse percentage comes from. To get rid of that 88, you're going to say 100 times 924, but you're going to divide by 88. It can be all over the whole thing, but you're going to divide it. So do you see the reverse percentage indicates that 100 is always on top. That's what it is. So if you could see that you're dealing with reverse percentage, it was probably not even necessary to show this equivalent fractions, but it helps you to understand that concept. So you punch this in on your calculator, okay, and you're going to get 1050. All right. So another thing worth avoiding would be if you were just simply putting 100 over 12 times that, you're going to get a 7,000 something, and there's no way the television can cost 7,000 because the reduction in percentage wise is not that much. It's just 12%. So the difference between 1,050 and 924, if you have to find the percentage, you will realize it's 12%. So let me just show you what I mean by that. Okay, just for you to have an understanding of what I mean. So if you take the 1,050, you take 1,050, now this is the cost price, and you take away the selling price, you will realize, okay, there is a loss that was made. So what is that loss? That loss is, let's say, 1,050, take away 924, you get 126. So there's a loss of 126. So that is like a loss. Okay, right. Let me just correct this little. Okay, so that represents a loss. If I ask what is the percentage loss, it will be that 126 over what did the item cost you, the original price, which we now know. If you take that and you multiply it by 100, okay, it's very interesting. So let's grab the calculator. So let's say we say 126, so 126 over 1050, and you express this as a percentage, which is multiplied by 100. Do you realize you get 12%? So this is equal to 12%, but the 12% has been given to you. Okay, you've been told. What you were not given was this cost price, and when you're looking for the cost price, the original price, the original amount, you are now dealing with reverse percentage. That means you have to do a little bit of manipulation in there. Okay, let's go to question 5. Question 5 says Ben covers a distance of 1,710 meters in 3 minutes. You're supposed to convert this and give your answer to or in kilometers per hour. Now, there are many ways you can do this. You can do this in stages. You can say 1,710 meters. If you divide by 1,000, because 1 kilometer is equal to 1,000 meters. So if I have to go from this meters to kilometers, I will divide. That gives me 1.71. Okay, you can write a 0 if you want. Now this answer is in meters. If I want to change 3 minutes, 3 minutes is 3 out of 60, since there are 60 minutes in an hour, because I want to change this to in hours. Then I take this. Now grab your calculator. It's not necessary for you to go and struggle if you can't see what that 3 over 60 is. And it's 1 over 20. And if you change it to a decimal, 0.05 is a decimal that terminates. So you can say, okay, this is equal to 0.05 hours. It's a small part of an hour. What part of an hour is it? 3 minutes out of the 60, out of an hour. Now you have your answer in kilometers. So sorry, this one over here is kilometer. Just write it nicely. So this one here is now kilometer. No need to put the 0. You have got the hours. This means kilometer, which is 1.7. So it's 1.71 kilometers. Okay. Don't have to write the units, but I'm just writing it. Divided, that per means divided. What is the hour now? It's 0.05. You can put H there. And you simply use your calculator. And then you find out what that answer is, okay? And then that is going to be 1.71. And I'm going to divide that by 0.05. Okay. You can leave your answer in many ways. It's either this improper fraction over here or 34.2. Okay, so the answer is 34.2. Right. There are many ways you can do this. Maybe I can bring in my whiteboard to explain a little bit what I mean by this. Okay, so if you have, let me just erase the stuff that I have there before. Remember, the question was saying you are supposed to convert 1710 meters it was done in 3 minutes. Now, if you were to grab that and you say, okay, let me change this to meters per second. That means meters per second. That means I must change this 3 minutes. Now, 3 minutes is equal to 3 times 60, which is equal to 180 seconds. So if I want to change, the 1710 is already there. So that means 1710 meters. And now I know my seconds, since it was 3 minutes, it's 180 seconds. If you now grab your calculator and you calculate this stuff, you will realize you get 9.5 meters per second. So if you now grab, let's say I just minimize this one a little bit. Okay, so I have got, so let us see. My whiteboard is a bit small. Okay, so that's what I have, right? So if I want to change 9.5 meters per second to kilometers per hour, and you do have this calculator, but of course it's not allowed because this calculator has got some programmable features, all right? But if you have it, good for you. So I will take 9.5 meters per second and I'm going to convert it to kilometers per hour. So I'm going to say shift and press this 9 here or the 8 here where it says conversion. So there are a lot of conversion. There are about 40 of them. So if you press the 20th one, then you can see that this thing says the calculator can convert meters per second to kilometers per hour. There's all other ones that can do the other way around. How many meters per second do I have? I have 9.5 meters per second. So if I hit 9.5 meters per second, it will immediately change it. Okay, that is the improper. If I change it to a decimal, can you see that the answers are identical? Okay, right, but there is a little bit of manipulation involved in this particular work. Right, so let's go back to our paper. Question 6. This question is also not something that is so difficult. You just have to substitute. Find the value of a squared minus 3b when a is negative 2. I'll encourage you to put those stuff in brackets. Okay, minus 3, open bracket again, b is 5. So it's just a matter of you manipulating anything squared, whether it's negative, that's why I put it in brackets, so you can read it as minus 2 all squared. That gives you negative 4. Minus 15. Of course, you're going to get a negative answer here, and the negative answer is 11, negative 11. So this is a 2-mark question. It means there needs to be a method that is seen there. So the method comes from either this substitution or this particular value. But there is no need also to get this type of questions wrong. If you simply just hit them up on your calculator, you say minus 2 all squared, and you take away 3, minus 3, in brackets, you can say times, but you can put a bracket like this. Of course, calculator gives you the answer. Okay, it will be slightly different if you just say minus 2 squared without putting that minus 2 in brackets, because now this is reading that the 2 is the one that must be squared, and then there's a negative that must be multiplied with that particular answer. So minus 3 times 5, and this answer will not be correct. You see, it's minus 19. Hence, you have to put that minus 2 in parentheses in order for you to get the correct answer, because the whole value of a is negative 2. So you can't put that negative outside and then you get the correct answer. Right, simple calculator tricks, but you should be able to master that. Question 7, so we are now delving into a bit of algebra. Excuse the noise, the background. closing the doors. Negative, negative, um, actually, algebra. That's what I want to say. We are now dealing in a bit of algebra. We're starting with the basics. You need to simplify. Here you multiply, obviously, you multiply the coefficients together, 9 times or 3 times 3, you can say times if you want to, and then you have x squared times x to the power 4, then multiplied by y cubed times y. Okay, let's put that 1, so there's a 1 there. Now 3 times 3 is 9, x squared times x to the power 4, you add the indices. So this is 9, that is going to be 2 plus 4. So that is going to be x to the power 6. Then you have got y here, you add the indices. That's why I wrote that. So that's going to be y to the power 4. Okay. Factorize completely. Here you factorize, you take out by grouping. So if I take these two terms, what did you have in common? They have an x in common, then y plus 6a is left. I need to find an identical bracket like this. Let's come to the other one. All the terms are positive, so there's no problem. 5 is common because 5 can go into 5, 5 can go into 30. And what else? C is common, right? So if you 5c into 5cy, you are left with y. 5 into 30, that is 6. And then c is cancelled, that gives you 6a. Can you see that these two brackets are identical? And when they're identical, it means you write everything outside the bracket, 5x plus 5c, in its own bracket, and you write y plus 6a in its own bracket because it's a common term. Therefore, you get the same answer. Okay? You don't have to repeat it again. Factorizing from 1, 2, 3, 4 terms to one term. Question 8. If you subtract 7 from the product of a certain number, let that number be x. So the product of a certain number and 3. That means that number multiplied by 3. Okay, just write that neatly. Product of a certain number. This certain number is x. And you subtract 7 from that product. The answer is at least. At least means it can be more or equal to 5. Because when I say give me at least $5, that means that is where you can give me. That is the lowest you can give me. It is $5, but you can give me more. Right. So that is the linear inequality that we have. The inequality is 3x minus 7 is greater than equal to 5. Now you solve the inequality in part B. Very straightforward. You solve it similar like you would be solving equations, but you are just going to remember that there are a few steps you need to do, and since the coefficient of x is positive, no need to worry about swapping that inequality. Since the 7 is subtracted here, when you take it over the inequality, you'll be adding. So you have got 3x is greater than or equal to 12. Right, this eventually becomes 3 or x. Let me just go ahead and write it, x greater than or equal to 12. Then x will be greater or equal to 12 divided by 3. So if this 3 was a negative, then this inequality sign will reverse. But since it's positive, no need for that. So the final answer will be x is greater than or equal to 4, because 3 go into 12 4 times. And your answer must be an inequality like that, not an equation. Don't put an equal sign. Question 9. Again, not complicated algebra. It is this whole thing should be expanding, means you create many terms. 2x should multiply with that. That is going to be 2x squared times y. Okay, I'll bring the minus because it's a positive times a negative. Then that 2x should multiply with that. 2 times 2 is 4. X times 1 is x. And y times y is y squared. So each one is b1, b1. That means you get an independent mark for the 2x squared y, and another mark on its own for minus 4x y squared. It's independent. Okay. Then that brings us to question 10. Of course, there is some square root involved with this one, and it's very interesting because you are now supposed to make x the subject of the formula. Okay, so many ways that you can do this. First, you can get rid of the square root, and in order for you to get rid of the square root, you will have to take the opposite of that, which is squaring both sides. So we are now going to be left with 4 in bracket. You have got x plus u all over v, because the root and the square have cancelled each other, and that equals to w squared. Now you can sort of multiply out. You can say 4x, 4 in bracket, x plus u, 4 outside the bracket. Then it's v times w squared, that is vw squared, cross multiply, so to speak. Now we can sort of say, okay, there are many ways I can do this. I can divide by 4, okay? Because when I'm here, there are other students, and I'll rewrite this again so you can see the two possible answers. But suppose I do not, okay, I do not multiply the 4 over, but I simply remove the 4 here by dividing by 4 here and dividing by 4 there. Okay, eventually, this gives me a scenario, okay, where I am now left with x plus u is equal to vw squared over 4. Then I can get rid of that and I say x is equal to vw squared over 4 minus u. Okay, this is my answer. Okay, this is my answer. So this would be my final answer for if I was to go that particular route. However, if a student was to say, and I will do this under, was to say at this particular junction, let's say he has got 4x plus u equals to vw squared, and the person does not divide by 4 like what I did over here, but the person goes ahead and say, okay, I am going to expand. That means I'm going to sort of expand. That is going to be 4x plus 4u is equal to vw squared. Then 4x will be left alone here. Then vw squared minus 4u. Then now the person says, okay, I can now isolate my x by simply dividing by 4. So I'll divide by 4. And since there are two terms there, all those terms must be divided by 4. And when you do that, you have got x equals to, since everything is over the same denominator, then you will be subtracting the numerators and just put over the same denominator. But if you look at 4 divided by 4, that gives you 1u. Okay, so this is also an answer that is also accepted, and you are not going to be penalized if you were to do this. So if a student was to give this answer, also correct, nothing to be afraid of. Okay, ultimately the two things are very similar. All right, so it's either you leave your answer like this or you leave your answer like that. Okay, the reason why you have minus u here, because if you look at 4 divided by 4, you're just going to leave u over u. But anyway, same thing. The beauty is you can always go back and in reverse or rewind the video to check. Question 11, you have got a pair of simultaneous equations or a pair of equations that you need to solve simultaneously at the same time. You need to show you're working. Now, of course, this one here, you have to be sort of familiar with different methods or ways of solving equations, okay? This one you can either solve by the method of making the coefficients the same by equating or equal coefficients, or you can make something the subject of the formula, x or y, which will be a little bit extremely too much work because you'll be dealing with fractions, or you can use matrices. But in this case, we're just going to use the straightforward way, old way of just making the coefficients the same. So in essence, I'm going to double or solve. If I look at 2 and 3, I'm going to make those coefficients the same. So the lowest common multiple of 2 and 3 is 6. So I'll make them to be 6x each. So for this 2 to be a 6, this equation should be multiplied by 3. That means the 2x times 3 will be 6x. The 3y times 3 will be 9y. And the 11 times 3 will be 33. To make this 3x a 6, or this 3 a 6, I will have to multiply this equation by 2. So 3x times 2 is 6x. Then minus 5 times 2 is minus 10. And negative 12, doubling that gives you negative 24. So I will now eliminate the 6x because the 6x contain the same terms. And in order to do that, perhaps it's important that you can put this whole thing in brackets. And I am going to do the subtraction. That means I'm going to take away this, subtract this term or this equation from that. 6x, take away 6x, obviously you cancel. 9 minus minus 10, that gives you 19. There should be a y there, 19y. Okay, let's go back and put our y. So there's a y over there. How do I get 19y? Of course, please, it's 9, take away a negative number. And that is the same as 9 plus 10. Okay, use your calculator. You have got 9 minus a negative 10. You get negative 10, but sorry, negative 10. You get 19. Okay, so same logic. 33 minus minus 24 is the same. 33 take away negative 24 is the same as 33 plus 24. Okay, if you add that, that is 57. Okay, you can use your calculator. So this means that y will be 57 divided by 19, which gives us the value of y. And the value of y is equal to 3. So now we know what the value of y is. I can go ahead and go put my answer there. Y is equal to 3. How will I get the value of x? It's very simple. I will substitute the value of y into either one of my original equations. So let's take the first equation. I can call this equation A, and that is equation B. This is C, and that's D. Doesn't matter. If I look at equation A is 2x plus 3y is equal to 11. But what do we know? We know that y is equal to, 3 from here. So we substitute that value for y. Then this is 2x plus 9 is equal to 11. That gives us 2x is equal to 11. Take away 9. When you say 11, take away 9, that gives us 2x is equal to 2. 11 minus 9. That will be x is equal to 2 divided by 2, which is equal to 1. So now we have our value for x, and our value for x is equal to 1. And that does it. All of this requires that we need to show our working. Okay. So quite many ways you can do this, but you are scoring method marks as you are applying your particular solutions. Let me just show you with this calculator that is programmable. Okay, not all calculators can do it. Okay, it has to be this. So if you were to say mode, you go to mode, okay, mode. You choose 5 for equation. Now it's simultaneous equation, which means I'm looking for 2 unknowns. I'll check equation 1. I'll choose 1. So what I'm going to put in, if I go to my original equation, so if I take equation A, the coefficient of x is 2, coefficient of y is 3 and 11. So I'll put 2. 2 hit equal to, okay? The b value is the one in front of the y. 3 is positive 3, hit equal to. And my value of c on the other side is 11, hit equal to. Now, I'm going to the second equation. My a, which is the one in front of x, is going to be 3, hit equal to. And my b is negative 5, hit negative 5, hit equal to. And here I have negative 12, hit equal to. Now when you press equal to, x is equal to 1, which is what we have. Can you see that? We have x is equal to 1. When you press equal to again, y equals to 3, magic. But this calculator is not allowed, because if you give your answers without showing your method, there is no mark. but I just thought it's interesting. Okay, let's go to the next question. That is question 12. So I'll pause video a little bit just so that you can at least go through the questions that I have done. Right, let's get to question 12. You are supposed to express 2 over x minus 3 minus 1 all over x plus 4 as a single fraction. Right, so think of this x minus 3 and the x plus 4 as going to be the LCM, or yes, then these two would need x plus 4 in order for it to be complete, because it already has x minus 3. Okay, then the minus 1 that you have over here, it has x plus 4, and it will need, you guessed it correctly, x minus 3. So now we will be expanding that numerator, which is 2x plus 4, 2x times, that is 8. That is if we were now to expand. So you'll have to do that and that. And then you multiply out here. That is going to be minus x. And a negative times a negative, very careful here, that gives you a positive number, positive 3. All of this, you do not, and I repeat, you do not have to expand the denominator. You can just leave it as x minus 3, x plus 4. There's no need for you to go ahead and try to simplify that further. Now from here, we're just going to say 2x take away x, that is going to be x. 8 plus 3, that is going to be 11. And then you go ahead and you put it over the same denominator, which is x minus 3, put them in brackets, as well as x plus 4. Right. Now, naturally, there will be people who would be going, overboard and try to multiply out the denominator, but there's no need for that. Okay, very straightforward, very simple. All right, so that is all. You have got a little bit of expansion to do at the numerator, and if there was a term x minus 3, you would have probably be factorizing it out, but that is the answer, and that's that. Question 13a is a linear equation. There's only one answer for x. Look at the solution here. So you have got minus 4x is equal to 10. So that positive 5 there, because it's a positive 5, you have to take 5 away here. You also have to take 5 away. That is why I'm going to subtract 5. I've got minus 4x is equal to 10 minus 5, which is 5. Then my x is going to be that 5 divided by negative 4. Now this is already your answer, okay? Or you can say negative 1, because 4 goes into 5 one time, and 1 is remaining, and then you have your answer like that. Any equivalent answer to that, 1 mark. Correct. This one, straightforward again. It's already factored the left-hand side, and since everything is equal to 0, the only way you can get 0 is either if you let one term equal to 0, or if you decide the other factor x plus 2 is equal to 0. Okay, so simply, if you take that one over, you have x equals to 1. Or if you take the other one over, you have x equals to negative 2. That's it. And remember, if you were to put 1 here, that thing becomes 0. And 0 times anything will obviously give you 0. The same if you were to put negative 2 here and negative 2 there. You're going to get 0 as an answer, because one of the brackets will be equal to 0. Right. Question 14. It is given that that whole horrible stuff is equal to the other horrible stuff, and you're supposed to show this. So it's a shown question. So the show question, you get the final mark, which is an E mark, but you need to establish this. So there is a lot of methods involved that you have to show, and your knowledge of dealing with indices, trying to make the basis the same, and then equate the indices, the exponents, is what is required here. So on the left, I have 3 raised to the power of 2x minus 1. Nothing I can do there. But 1 over 9, that is the thing. 1 over 9 is the same as 9 raised to the power of negative 1. 9 is the same as 3 squared raised to that power, which is the same as 3 raised to negative 2, if you get my drift. Okay, but it also contains a what? It contains an x. Contains an x. There's an x over there, so there's an x. So eventually, this one here can be written as 3 raised to the power of negative 2x. Then that should be multiplied by 3 raised to the power of 2y minus x. Now, nothing that we can do on this side, so I'm just going to write as it is because it's just one term. But on this side, when you multiply a to the power m times a to the power n, when you multiply and the bases are the same, you add the indices. Okay, so that means I have 3, then I have negative 2x, then I will be adding 2y minus x. I'm adding the indices. Now if I do that, and I have 3 here, 2x minus 1, and if I come here, adding the indices, well, nothing I can do with the 2y, okay? But if I say minus 2x plus minus x, that gives me minus 3x, very important. Then you have got plus 2y. So in this case, there was no need for me to put the brackets there, but because it's a habit, especially if you're subtracting, which will affect that. So what is it that I have now? I have now that these exponents are equal to each other because the bases are equal. So if the bases are equal, then we drop the bases. And if we drop the bases, we equate the exponents. When we equate the exponents, I will say, therefore, I have now established that 2x minus 1 is equal to minus 3x plus 2y. So I only get a mark for establishing this if I have to show a valid method here. So that will be 2 marks for the method and 1 mark for establishing that fact. So you can't get a mark for establishing this answer that you were given 2x minus 1 is equal to minus 3x plus 2y if you didn't show by means of this method that you are getting to that. So the application of that skill is important. And I've done a little bit of side work to assist me and to assist you to understand certain concepts, and I will advise you to do the same. Okay. So this one, I will just call it my side work. Please remember that you are not to write on this margin here because this is where actually the marks are all located. And this is a 3-mark question. Good. When we come to question 15, question 15 say you must express this as separate log. Right now it's a log with one, it's a single log. Okay, and many ways you can do this, but let's suppose I say, okay, this means log 3, the cube root of 3, because I'm subtracting, the numbers are being subtracted, and if you have a log of the numbers being subtracted, it's like you're subtracting log of the same basis. Okay, we are halfway there. I think you already get a mark for that. If you were to calculate further, the cube root of something is the same as that something raised to the power of a third. Please remember that. So that means this is log 3 of a third minus log 3. Now using the power law, putting that 1 over 3 in front will be 1 over 3 log 3 minus log 3. Guess what is in front of this log? There is a number 1 here. And if I was to say 1/3 minus 1, because this is like terms, this is the same scenario as a third of x minus x. Okay, there's a 1 there. So if you say a third minus 1, which is negative 2/3, so you are saying, okay, let's just go back to here and get our thing to the correct mode. Okay, set up. We'll go back to computation. So it's the same as 1 over 3 minus 1. Guess what? It's negative. Okay, let's go back. 1 over 3, a third minus 1. Okay, 1 over 3 minus 1. Okay, good. It's minus 2/3. So this log 3, think of this log 3 as an operator, like an x. Just subtract the numbers in front. Then that means I will get here negative 2/3, but I don't put x, I'll put log 3. Right, so this is my solution. But if you were to write it like this, it's also a solution that accepted because you wrote it as separate logs. But it just so happened that this log here, 3, and that log 3 is common, and I would have like terms being subtracted, I could actually further simplify it. But if you were leaving your answer like this, or if you were leaving your answer like this, you are going to get the full marks because you already separated them. But when you separated them, I realized, wait a minute, there is more that I can do here, okay, unfortunately. So it's something that can also award a mark to a student because this 1 over 3 minus 1 give me this negative. So as much as I said separate the logs, it simplifies to something like this. So for this particular instance, that student will be getting that mark. All right. But 2 marks here is already enough. The reason why I went further, and you will see why. They say if log 3 is equal to m. Now, from my answer at A, I have minus 2/3 log 3. So they are now saying, if this log 3, this one here, is replaced by the letter m, we need to determine that value. That is simple. The value of this, which we now have as that, or we have as that. So now it's simple. I would say, okay, that simply means I'm going to have negative 2/3 of m. And that is done. My answer is finished. There's no need. Or if you didn't want to use that answer, and you are going to that part where it says a third log 3 minus log 3. Remember where I said you get a mark, this one, it could be, if I like, let me highlight that, maybe with another one. I'm now talking about this, okay? Might be a little bit dark, but I think you'll get the concept. That third, or this one over here, rather. What will that value be? Right, let's see. It's the same as a third m, because it's now for log 3, minus m. That is going to give you nothing but minus 2/3 of m, where I did this before I put x's. Can you see that? Right, so whatever method you take, you'll get to the same concept, same condition. Let's go to the next question. Sequences in an arithmetic progression. So very important, this is an AP, there must be a common difference. Okay, because they want us to find the common difference. What do we know? We know that the 6th term is equal to negative 2. What else do we know? We know that the 14th term is equal to minus 18. Okay, so we'll create two equations here. Now, let me say something so you can get it. The formula is T sub n is equal to A plus, well, I'll put n minus 1, and I'll put my d over here. Doesn't matter where you put it, okay? So the 6th term, if it's 6, I'll have A plus 6 take away 1, d. So it's going to be A plus 5d, it's always 1 less. That is the 6th term, right? This is equal to the 6th term. But what were we told? What is the 6th term? So A plus 5d is equal to negative 2. this is going to be my first equation. What else do we know? We know that the 14th term, that is t sub 14, is equal to a plus 14 minus 1 times d. So the 14th term will be a plus 1 less, always 13 d. So I'll take this one, I'll say, okay, the 14th term will be a plus 13d should give you what? Negative 18. And that is going to be my second equation. So this one over here, the first one here is the 6th term. This one over here is the 14th term. So you realize there's always one less than that because you're saying n minus 1, one less than that. So if I was telling you what is the 7th term going to be, it will be a plus 6d. What is the 12th term going to be? It will be a plus 11d and so on. Now that I have these two equations, you are now going to solve these equations simultaneously by subtracting them from each other. So I would be saying, if I now subtract equation B from equation A, okay, and this is very important that you understand that. You subtract the A's cancel, then you have 5 minus 13, okay? So maybe I should just move this a little bit out of the way in order for you to understand what is it that I'm doing here. Okay, so I'm going to subtract equation B from equation A. The A's cancel, but 5 minus 13, very important that you see that. That is negative 8D. Negative 2 minus negative 18, that's negative 2 minus negative 18, is the same as 18 minus 2, because this is the same as a plus here. Okay, use your calculator, which is what? 16. Now we can actually calculate the value of D. The value of D will be 16 divided by negative 8, which is negative 2. And I can go ahead to my space and I can put my value of D, which is negative 2. Right, how will I now calculate the value of A? Now I can use either one of equation A and equation B. Doesn't matter. So I'll use equation A. Equation A was nothing but A plus 5D equals negative 2. I could also have used the second one if I wanted to. Doesn't matter, you'll get the same answer. Right, what do we know? We know that D is equal to negative 2. So this is A minus 10 is equal to negative 2. Please make sure that you can do the correct thing. Then A equals to minus 2 plus 10, when you take that 10 over. That is the same as 10 minus 2, which is 8. There I have my answers for A as well as my answers for D. Okay, so make sure that you understand how to use the correct formula for the correct progression. This is an arithmetic progression. Okay, let's go to the next question. Question 17. You are given a trapezium and you were supposed to calculate the area of a trapezium. So you now need something, knowledge. You need to know how to calculate the area of a trapezium. Okay, the formula is something that comes from the lower grades that you should know. The area of trapezium is the sum of the parallel sides being the 4 and the 7. So if the parallel sides are represented by letters A and B, the sum of the parallel sides, obviously half of that times the height. So in this case, my area would be sum of parallel sides, which is 4 plus 7. And I'll multiply that by the height. And the height is the distance between the two parallel sides. So my height is represented by this distance. Okay, always the same height. So the height there is times 4. Then I'm going to divide all of this by 2. Okay, now if you were to calculate 4 plus 7, it's 11. 11 times 4 is 44. 44 divided by 2, that gives you 22. So the final answer here is 22 square centimeters. Okay, plug it into your calculator and you will have it. So this is my height. Okay. So that 5 was given to you only as a decoy. There's nothing you can use for that 5. Unless they ask you to find the perimeter. That means the distance all around that shape consisting of straight lines. Question 18, a little bit of sets questions. So we have got the first one. We have the Venn diagram, A, C, and B. As you can see the sets. And then you can see other things that are not in those sets, that are outside, like the 10 and 11. The first one, you must write all the elements of set A. I would advise you to write them in an order, chronological order. So obviously set A1 is there, 2 is there, 4 is there, 5 is there, 6 and 7 are also in there. These are all the elements. Okay, list the elements and then you can put them in those curly brackets. Part B, set A and B, the intercept, what do they share? What do they share? They share the 4 and the 5, as you can see. So here is nothing but 4 and 5 for 1 mark. Part B or A Roman 3. The union of set A and B complement. If you take the union, everything in A and B together, what is not there is the stuff that is in the outside, which is 10 and 11. And you can see they are on the outside. So that's simple. Here you will be writing 10 and here you're writing 11. Okay. Part B. State using set notation the relationship between set A and set C. Now if you look, set A is like the mother and set C is like a child. Okay, so this is an element of A. You can also say that. And set C is an element. No student will be punished by saying, well, set C is an element of set A. But there's also something else that you can say. Okay? When you're part of a set, you're an element of a set. So it's a member of these 6 and 7, is a member of that. As you can see them already there in set A. Or there is another one. We can say C is a subset of A. Okay? What does that mean? I'll write it here. A set whose elements, whose members, okay, are all, that's all, members, okay, of another set. Like this C, the 6 and 7, they are all members of set A. So we say that C is a subset. And what is the notation that we use? We say the notation is C is a subset of A. So either one of these deductions will give you 1 mark. Now, since A is like the bigger one, like I was saying, the mother, and the other one is the child, then that A is also, just to add in a little bit of more spice, A is called, okay, not that it's necessary for you to know at your level, the superset of C. Okay, but you will be getting a mark if you were either writing C is an element of A, or if you were writing that C is a subset of A. 1 mark for that. Okay. Right. Take a little pause and we start with question 19. Question 19. Question 19. The diagram shows the position of 2 people. Now, I've sketched it here. It says the bearing of a third person R is from A is 062 degrees. Okay. From A, that means you go to A, you draw yourself an angle of 62 degrees. Okay. The bearing of person R, where this person is, from B is 275. So 275. So here's the thing. You already determined where your person R will be, okay, and perhaps when it says the bearing of something from something, like R from A, you always go to what is after the letter from. That is why I have 62 degrees over there. If it says the bearing of person R from person B, from B you go to B, and when you're at B you need to find this whole angle of 275. So you cannot draw an angle of 275. You can see it's a reflex angle. So what you need to do then, you say, wait a minute, how will I find my 85 that I indicated here? I'll say the whole revolution thing, 360, minus the 275, there's where the 85 come. So I'll be taking my protractor and I will draw or construct or draw, if I have to say that again, an angle of 85 degrees by switching my protractor around. Once I have that 85, I draw the line. Here the 62 degrees, I draw the line where they intersect. That is the position of person R. And then you label it person R. So let's do that so you can see, okay? So I've got a bit of software here. All right, so I have the question over here. So I bring my protractor at A, remember? I put it nicely at A, so it's going to be a more or less thing, okay? And I want an angle of 62 degrees. 62 degrees. So the sketch helps you a lot there, right? You say, okay, 62 degrees. Take my ruler, and I can see where 60 is from 0 up there. 62 is somewhere here. So I'll just use my ruler, and I move it closer to where 62 will be. Okay, so there, more or less. Okay, more or less. And then I'll say, okay, let me draw that line. Right, so I'll draw it. Did it highlight the pen? So I'm going to draw that line. There we go. Draw that line. Right, so that is the 62. Good. Now I have to find the 85 because I cannot draw an angle. Okay, because up to there is just 180 and then I have to turn it again and I have to turn it again and so on. So I said, okay, let's just take the protractor and we turn it around and we draw an angle of 85. Okay, so let's see if we can just move it along. I think it's pretty much positioned well. Okay, will be more or less out there. So my 75, you cannot start obviously from here. It's an acute angle, so I'm using this 0 in the inside. So you can see 56, 70, 75. So let me take my ruler again. Maybe just sort of change the, so that it can exactly go to that 75. So let me just have it there at the center. 75, 60. Now it gets to 70, so we just go a bit down. 75 will be over there, more or less. Okay, maybe you should just move back a bit. Let's say there. But here we moved a bit, so we have to come this side again and move it a bit. Okay, so we have what there. All right, I'm not totally happy with my 75 there, so just move it slightly, like so. I think you get the idea. Okay. There we go. Right. The reason also why I make the ruler a bit longer because you want them to intersect. So don't draw short distances. All right. So now you are going to draw it. Now, once you have done that, if you take away the stuff, okay, there is where obviously your R will be. It will be here. This was where this was where um, this was where the angle of 62 degrees was. This was where the angle of 85 degrees was. Can you see that? And there's where my angle R is. That makes perfectly good sense. I think we have it and we understand it now. Good. Now, this sketch is quite important, so you just bear with me because I want to sort of crop it so I can use it. And let me see if I can just bring it. Okay, so I'm just going to snip it, maybe rectangular snip. snip it, and then I'm going to carry it over onto my annotation or my document. Okay, and I will say this is obviously question 19A. So I'll just say, okay, yeah, I want it, and I say this is question 19A. Right, let me save that, and I'll go to my document, because what I did is I created an extra, I added or inserted an extra page, I appended it, okay, I added an extra page, and that will help me to sort of, I'm showing you the software. Once you get the software, the PDF annotator, then you know less more how to do it. So I penned it, pen page, insert page, pen page. All right, so I'm going to paste it over here. Now let's bring our document. So this is the stuff that we did over there. Very important. So it will not be able to take away. Oh my goodness, let us just go back and say, good, there we go. Now, we can perhaps now even look at answering the next questions, because we did that. That's 2 marks. Part B, Roman 1 says calculate the bearing. There's no construction. There's no protractor. Use what? Here you just have to use calculation. The bearing of A from R. And what is the key word that I say? You must always go to what is after the word from. So that means, and I'm going to use my drawing here. I'm going to draw another sort of a, I'm going to bring in another parallel line like so, okay, north line, okay, so that is going to be my north line. You can put this as your north line, right? And if they ask you questions like find the bearing of A from R, so you have to go to R. What is the keyword? You go to R and you go, start at the north line, you go clockwise, and so. So this is the whole angle. So you can see it's already 180 plus something. This something happens to be 62 as well. This is 62 degrees over here. Okay, because you see that alternate, that's Z. And this other one here all the way is 180. So the bearing of A from R is the same as 62 degrees plus 180 degrees, okay, which if you calculate it is 242 degrees. Okay, that's one way of answering that. So let me just go back and put my answer in my answer space. So this is 242. Or another way that you can calculate that, suppose you didn't want to put this little 62 over here. You should know that if you have two parallel lines, one is like, oh my goodness, one is like so, right? And the other one is, let's say I bring it over here. And for simplicity case, let me just bring this one down so they can just look exactly the same. If you had like what I have there, I have it like this. The lines are parallel. I know this angle here is 62 degrees. I should be able to calculate this angle because co-interior angles, they add up, they are supplementary, they add up to 180 degrees. Essentially, that little dot that I put there, if I want to find out what that angle is, it's going to be 118 degrees. Are we together? Now, if this is 118 degrees, my A was here, my R is here, okay, and I am looking for this bearing from the north line here all the way up to here, then I can say, okay, 360 minus that 118, guess what you get? You get the same answer. So that's also another way that you could have solved that. Okay, let's go to the other one. The other one saying the bearing of B from R. Okay, so I think I can bring that diagram of mine again. Just bring in more values so that at least I have got the bearing of B from R. So B from R, let's write it, the bearing of B from R. I said go to R after the word from. That means we have to go here. Let me just introduce my north line so that they can be parallel. So this is what is there. Okay, I just correct it now a bit. So let's just move it so that it can, you know. So let's just undo it if it wants to play games. Okay, let's go and put our north line just a little bit nicer. I think it's now better. You agree? Okay. So this is my north line. The bearing of B from R. You go to R, what direction? Clockwise. That is the angle we're looking for. This is co-interior. So I can find this angle plus this 85 should give you 180 co-interior. So I will say, wait a minute, it's 180 minus 85. Okay? When you do that, you get an angle of 95. But we are looking for the bearing. It should always be a three figure. So you need to put a 0 there. So it's 0.95 degrees. The other one is already a three figure, 242. So my answer is 0.95 degrees. 0.95 degrees. There we go. All right. So I had to bring in a bit of sketches in order to give you the concept for that. Let's go to the next question. You have got similarity here. Two similar cylinders have height 3 centimeters and 6 centimeters respectively. As you can see, the volume of the smaller one is 30. What will be the volume of the bigger one? Now, I like to simplify things. All right. It doesn't matter if you were to take the smaller one. Let me take the length. The small length divided by the long one, which is a half. This length, but I cannot say a half is equal to 30. Volume means I must cube. So I'll take that 1 over 2 and I'll cube it because I'm dealing with volume. And I know the other one's volume is already cubed, which is 30. But the bigger one I don't know, so I'll put an X. Okay, I could have done the other way around. I'll show you now. So from here, it becomes simply a matter of you calculating that and do cross multiplication. Okay, so this is 1 over 8. If you punch this in, 1 over 8 equals to 30 over X. Cross multiply there. You will get that X equals to 8 times 30. When you multiply, that is 240 centimeters. Okay. What if someone said, well, I am not going to take the 3 over 6. What if I'm going to say, I'm going to take, because what I did here, I took the small one over the large one. Okay. So what if you take the large one over small? You take the large over the big over small and cube it, and the large, which is what we don't know, but the small we know the volume is 30, right? What we know, the large one was 6, the small one was 3. They should be cubed over X over 30. Comparing, this is 3 into 6 is 2, that is 8. 8, then 8 is the same as 8 over 1. Okay, can you see? You will still be getting the same solution, because if you now cross multiply, you will still get X times 1 is X, and 8 times 30. 8 times 30 will still give you 240, okay, which is the same thing. Okay, it's a 3-mark question. Very important that you show your methods. Let's go to question 21. A shop sells shoes for both adults and children. Matrix A shows how many of each type it has in stock at the start of the week. Matrix B shows the number of each type it sells in a particular week. Calculate how many shoes the shop has in stock at the start of the week. Now this is very straightforward. At the start of the week, this is the matrix. 1, the number of shoes there. That means you just add everything. Okay? We are not giving our answer as a matrix or anything of that nature. We just want to know how many shoes are there. There were 75 male child plus 42 female child plus 121 male adults plus 154 female adults. These are the number of shoes that are there. Adding them together gives you 392. 1 mark. Okay. When you come to part B, calculate the number of female shoes in the shop, of female shoes the shop sells over the week, rather. Okay. The ones that they sell. Female, that means you come here. Okay. You come here. Female. Just add those ones together. It's very straightforward. 26 plus 33. Okay, that's 26 plus 33. Guess what? The answer is 59. Okay, it's 59. Now, calculate the number of each type of shoe still in stock at the end of the week. Give your answer in matrix form. So let's take what we have in the start of the week. We have 75, we have got 42, we have got 121, we have got 154, okay, start of the week. Then minus whatever is at the end of the week, because at the end of the week, this is what we have now. So if we subtract, just subtract the elements with the elements. It's 20, it's 26, it's 25, 33. So this becomes very straightforward. You will be subtracting. You will be subtracting 75 minus 20, 42 minus 26, 121 minus 25, okay, each corresponding 154 minus 33. 75 minus 20, 55, remember it. So this particular answer, because I already put the answer there, this is going to be 55, okay, just to give you 42 minus 26, that is 16. Next one, 121 minus 25, that is 96. And the last one is going to be, bring my calculator back, 154 minus 33, 121. Those in blue is what I have as the answer, and I put it right there for you to see. Okay. That's all. Let's go to the next question. Question 22. The masses, how heavy 12 soccer players are in kilograms, are given below. If you count them, you will see there are 12. The mode rhymes with most. Mode, most, and it's 73. It appears 3 times. It's the only one that is appearing the most, so it's 73. Okay. Range, big value, 73. Minus smallest value. If you look at the smallest value in that quickly, you see the smallest is 61. 61 is the smallest. Answer is 12. That's range. We're done. Mean, you must add all of them. So it's the sum of the values, and you are going to divide that, sum of the values, you divide it by the number of people. It's 12. Now, you can grab your calculator and start adding. Okay? Okay, don't have to write. You just go ahead. Okay, 73. Since there were 3 of them, so I'll just say 73 times 3 plus. Then I have 70. Then I have 67. Then I have 68. Then I have 62. Then I have 61 plus 65 plus 67 plus 72. Hit enter. I think I left out 1. 1, 2, 3. So I have 70, 67, 68, 62 is missing. No, 62. 62. Well, let's start over. No problem. Okay. I have 1, 2, 3, 73. So 73 times 3 plus 70 plus 67 plus 68 plus 62 plus 61 plus 65 Aha, another 65. There were two of them. Plus 67 plus 72. Good. 816. I feel better. 816. 816. Divide by 12. When you take 816, you divide by 12. Okay, good. So we take that answer. We divide our answer by 12. Okay, 68. 68 is my mean. Done. Dusted. Okay. Right. That brings me to question 23. Make it slightly smaller. In the diagram, O is the center of the circle line. AB is a tangent at E. The thing about that is you must know that perhaps I can just bring it in. That the tangent, this whole thing here, makes 90 degrees there. Also on the other side. That's why that is important. Then we are told that that tangent is also parallel to that. So there is a lot of things that come in. Let me first see what I can do, what I can calculate, just from the drawing over there. If this is 140, this whole thing here is supposed to be a revolution. So if I say 360 minus 140, I will get 220. So this part here, all the way there, that is 220 degrees. Okay. The angle at the center, this one here, subtended by the arc. You see this, not arc, the chord, DE, this chord, it sort of creates that angle there. The same chord also creates the angle at the circumference there. Can you see that? Right? So it's like if I had to, this chord over here, this chord, it creates that angle there, the center. It also creates the angle there at the circumference. Because of that, okay, because of that fact, the angle at the center, this 140, is twice the angle at the circumference. So x is going to be 140 divided by 2. This angle here will be 70 degrees. Angle at the center theorem. Angle at the center, subtended by the same chord or the same arc, is twice the angle at the center, at the circumference, subtended by the same chord, DE, or the arc. Okay. Right. What else can I calculate from using the same thought process? This angle 220 is also being subtended by this, creating the 140 and also creating the 220. So that 220, so Z will also be 220 divided by 2, because this 220 is twice as big as whatever this is, because it's being subtended by the same chord at the center and also the circumference here. So this Z will be half of that, which is 110. Okay. I think we are getting there somewhere, somehow. Another thing worth mentioning, if you look at this triangle, so I'm working on a diagram. I just want to make it a little bit lighter. This triangle here, this triangle is an isosceles triangle because this is radius OE. This is radius OD. Same. So if the interior angles of that triangle, which is blue, whatever the color is, the sum of the angles of a triangle should add up to 180. So this is 140. So there's 40 to give you 180. And that 40 will be shared. So this little one here over here is 20 degrees. This one over there is also 20 degrees. Okay, good. Why is that important? Well, that is important because I can actually calculate my angle Y. Because in order for me to calculate my angle Y, I will have to understand a little something. I can actually calculate it. If you look at angle Y, right? Now let us talk about the parallel lines. Okay, for you to find W. You see this whole parallel line. Let me bring in maybe a highlighter, and then from there, so sometimes when you work on the same diagram, it forms a Z from there. Okay, comes down, comes down, comes down, comes down, forms a Z. So which means these 90 degrees over here, this one, that 90 degrees is equal to W plus 20, because this is also supposed to be 90 degrees, because it's, let me see, did I get it correct? W plus that should equal to, not that 90 degrees. Let us just correct it a little bit. Made a little bit of a blunder, okay, because that is not, W plus 20 will equal to whatever this is. Now, let me just, again, ooh, all right, software is giving us a little bit of a problem, so I am going to just save the work, and I am going to, or continue. Just bear with me. I'm going to close it, and I'm going to open up again the paper. Okay, right, so if I go to my desktop, the paper is here. I'm going to open it with the PDF annotator, which is something that you buy online or software. It's going to go back to, and I'll just restore. My God, let us just make sure that we save. Right, now what I was saying, let's take away that, let's take away that 90 that I was coloring in there. So let me just bring in my eraser, take away that 90. Okay, I can leave it. I can work on that. Let's just use a different. So I want to use this concept. This whole angle here, which is W plus 20, is equal to this whole angle here. Since this whole one is 90, that little one is 20, it implies that this one is 70. Can you see that? This one here is 70. So this 70 is equal to that W plus that. So what does it imply? I can calculate W. W will be 70. Take away 20. Guess what is W? W is 50. Okay, I got my W. I have my W here. It's 50. Right. Can we also calculate Y? It's very easy. Even if you now to do again the same story. Okay. See, I'm already calculating the missing ones. Now, you can calculate Y in many ways. You can take this 70. You can take that W50. You can take the 220, and it's a 1, 2, 3, 4, and then subtract from 360 to get a Y. But I can also find Y very easily by saying, because I went the Z this way, I'm going to go with the Z the other direction. So I'm going to bring in another highlighter. So let's take, what will it be? Let's take this gray. If I make my Z here, going from this way here, this way here, my Z. Can you see that this 70 here is equal to this one here? Okay. So if this is 70, then this 70 plus Y should be 90 degrees. Why? Because of the tangent to radius. This side is also 90. Then Y is easy to determine. Y will be 90, take away 70, when Y will equal to 20. So I have my solutions. I've worked on the diagram. So work on a diagram, encourage you to do that. Find the angle of X. X we determined 70 degrees. Okay, X is 70 degrees, and we were saying I took 140 divided by 2. Y we determined Y was 20 degrees. Y was 20 degrees, so my Y I calculated by saying Y was 90 minus 70. Okay, from my side work over there. What is the next one? Z. Right, Z, we already determined Z. Z was 50 degrees. Okay, Z was 50 degrees. How did I get up 50 degrees? Well, many ways that you can do it, okay? Z was 50 degrees. And where is my Z? Z is over here. Z is 50 degrees. Z is not 50 degrees. Z is 110. Sorry, my bad. 110. So let's just clear that. Z is 110. Oh my goodness. Um, all right. The software is a little bit um, tricky, but we are going to continue. You can also take this moment and drink tea and coffee. Okay, let's go back to our diagram. I said my Z was 110. So Z, 110 for 1 mark, 110 degrees. Okay, then the last one was W. And W is the one that we said is 50 degrees. That W over there, here, the one that I calculated there. Okay, can you see that? All right, so W is 50 degrees. So I'll get those answers by working on my diagram. Okay. Right, let's go to the next question. Question 24. All right. It's very important that you take these things step by step. Remember, this is a 3-hour long thing. So I'll be pausing the video from time to time. Right. We are now at question 24. We are supposed to express this function here, minus y equals to minus x squared plus 2x plus 3 in vertex form. So this is standard form, and this is vertex form. So vertex form, since this is a minus, if you were to sketch this graph, it's going to have a maximum. That's how it's going to be. Okay, because the value of a is less than 0, it's negative. A being the value, remember, standard form is y equals to ax squared plus bx plus c. So the a that I'm referring to is this minus 1. So this point here, that is the maximum point. We also call it the turning point. So it turns. Now, one of the things that you need to know, whenever you deal with a quadratic equation formula, and there's no need, but I'm just showing you something else here, right? The solutions is minus b plus or minus, then it's the square root of b squared minus 4ac, everything here over 2a. Okay, now we can separate this. It actually means x equals to minus b over 2a. Then it's plus or minus, because we have a positive answer and so on, whatever. There are two solutions. Let's suppose the stuff here, the b squared minus 4ac, let's say that b squared minus 4ac, let's say what you're getting there gives you 0. Okay, so let's say you get a 0. So anything over that, so this whole thing on this side becomes 0. And the way that that becomes 0, b squared minus 4ac, if you were to plug in that value there, it means that your sketch, if we were to plug it in, you will get only the x value of the turning point. If I just take this part here, you are going to get the x value of the turning point, which is that value over there. So if we had a graph, so this was a graph, just for some reason, that is the y value, and that will be the x value. So this value here, the minus b over 2a, is what we call the axis of symmetry. The axis of symmetry. Okay, because it's symmetrical. If you were to draw that curve, it's symmetrical. It's like a line of symmetry. The whole curve on the left will equal to the curve on the right in terms of its symmetry. So that's the x value, the axis of symmetry. And it's possible for me to find what that y value will be if I know what the x value will be. So why is that important? If I can find that x value, then I will plug that x value into my equation to find the corresponding y value. And that will give me how I can find the x's, how can I find and write this in vertex form. All right, let me just take it off and make it much clearer also, because um, I have included a sketch, okay, or graph. I actually graphed that function. So you have two ways of writing that. You know that a value, a is -1, so a can be identified. We know how the function will be. It will have a maximum. The stuff in the middle there is the vertical translation of the graph. So if I take that x equals to minus b over 2a, and I know my b value from my standard form there, b is equal to 2, and I know that a is equal to -1. So if I had to substitute my b value divided by 2 times my a value, all right, this is going to give me that x is equal to +1, +1. So what does it mean? When I write it in vertex form, I will say y equals to, my a is -1. Inside here, it will be opposite of what this is. If this is a plus, here I'll put x -1 all squared. Because the stuff inside the bracket, this x -1, it refers to the horizontal translation of the graph. So if I was to say x -1 is equal to 0, the stuff inside, if I say equal to 0, then x will equal to 1 if I want to find that turning point. That x equals to 1 is the turning point. It's the x value of the turning point. So I can just go ahead and write it down there. Now for me to find the y value, what will be the output? I'll take this x equals to 1 and I'll put it back into the graph or into the function for me to find out what will be its corresponding value. That value, ironically, is also the value of q. What does the value of q represent? It represents the vertical up or down movement of the graph. So if I was to say, okay, let me substitute this x equals to 1, or this one, into my expression, okay? I'm just running out of space there a little bit, but let me bring in my whiteboard. So just to remember, where is my whiteboard now? Well, I can simply also do it here, all right? So I'll just use a different color. So if I was to take f of 1 into my expression, -1 squared plus 2 times 1, that is that value, plus 3. If I was to put 1 into my original function, I am going to get an output here. Okay, so this is -1 plus 2, that is 1, 1 plus 3 is 4. So that ironically is also the value of q. So q will equal to 4. So here, this expression will be, if I have to rewrite it here, the one that we are looking for is going to be y equals to -1, which you don't have to write, the -1, x minus 1 all squared plus 4. This is the vertex form that I'm looking for. There are many ways, but if you're using the axis of symmetry, if you use this formula, whatever that value is, it gives you the x value. When you put it back in here, it must now be the reverse. So if that x value is positive, then here you put a minus. If that value was negative as you calculated, then here you put a positive. Okay, the 4, the q value, that is the up or down. How many places is it going up from 0? Okay, you find that by taking that answer that you got for x, put it back into the original standard form, the original function. That output is the value that you get here. So if it's a +4, it means it goes 4 places up from the x-axis. Ironically, I told you that value is also the vertical translation because the turning point, where the graph is turning. So the coordinates here for the turning point is 1, 4. Now, let me bring the graph in so that you can get an idea. If you look at the graph, because I drew it here, here is how the graph would be. Can you see that the turning point of the graph is at the point 1, 4? That is the turning point of the graph, 1, 4. Another thing, can you see that the graph, the highest point, the maximum point is where y is equal to what? 4. That is the vertical translation of the graph. It went up by 4 places. Can you see that? Right? And the graph is slightly to the right side because the positive 3 that you find here, this is the y-intercept. And the y-intercept, if you have to write the function down, it was y equals to, let me just write it down again. So I'll encourage you always to also write maybe like this. Y equals to minus x squared plus 2x plus 3. The plus 3 is the y-intercept. Can you see that? Now, here's the thing that I probably have to just, how would you not know whether the graph is going this way, for example? Okay, just remember it will not be somewhere there on top. How would one say that, okay, the graph is it either going to my left or is it either going to my right? What will determine that that graph is going, as you can see, this graph is going to the right side? It is that y, that value that you have, that x minus 1 all square, this stuff inside, just the stuff inside here will determine. How do you know? It will tell you that the graph will go once, it will have a translation to the right side. Because if you have x minus 1 and you let x minus 1 equals to 0, x minus 1 equals to 0, then x equals to 1. So it means the graph is translated once, okay, to the right side. I hope that makes a little bit more sense. All right. If you have a plus here, the graph will go. If you are saying plus, then the graph, suppose there was a plus here, okay, that will give you -1. -1 means the graph will go in the opposite direction. Okay. All right. Let me just, for the sake of I'm going to remove that, especially with the drawing, the black drawing over there. Just go to the software so I can show you. Of course, we didn't ask you here to draw that. So let me say I bring the software in. Let me suppose I remove everything here that I have. Okay, for now. Let me just bring in a new one. And we are going to draw that function. I'm just going to open a new one. Okay. And this is also freeware. You find the software is free, downloadable. There are versions that are downloadable, the classic. Okay. Our graph was y equals to minus x squared. So I'm going to have minus x squared plus 2x, then plus 3. That's our graph. Okay. This is our graph. You can see it. Now, if, let me just have the label. So let me just say the name. At this instance, you are also getting used to, I'm just going to have the value, okay, the graph. So that's the value, that's y equals to that. If I take the same graph, and if I was to write in vertex form, it's y equals to, it was in -1, I can put -1, then inside the bracket was x, was it x plus 1 in vertex form? It was x, our answer, x minus 1. Okay, x minus 1. So it's going to be x minus 1 minus 1. You follow? Again, I hope you can see. Raised to the power of 2. Raised to the power of 2. Okay. Plus 4. Okay. Now 1 equals to x raised to the power of that plus 4. Let's see if the graph. Now, the reason why it's exactly the same place, if I uncheck that one, can you see? There's the graph there. Okay, I can maybe use a different color for you to see that I get the same graph if I make it in, so this is red. Okay, pink. Right, so it's G. If I uncheck that one and I take the black one, can you see it's the same curve? So that one was written in standard form. This one is written in vertex form. Now let me come to vertex form. There's a reason why. And I'll just uncheck. If I change in here and I put a plus 1, okay, plus 1. So you can see what will happen to that graph. You see that now, if I put a stuff plus 1 here, the graph goes to the left. Okay, so if this is positive inside, the graph will go to the left. If this is negative, the graph will go to the right. Okay, after its intercept point. Okay, that is very important. So the stuff here inside, it gives you the horizontal translation. Ne? And this number here gives the up or down. So let me just put in another value. Let me put plus 2. So you can see what happens again to that particular graph. Can you see? It shifted more so. It shifted 2 places to the left. Okay, right? So that is very important that you need to know that. Of course, it obviously is going to change because it's not the same as the other one. This is a totally different function. If I put minus 2 there, just to show you the translation of the graph, minus 2, it goes 2 places to the right. How will you know it goes to the right? You take x minus 2, let it equal to 0. And x minus 2 equals to 0 will be x equals to 2. What is that x equals to? That is the value here, the turning point. So if you say x minus 2, if you take that part and you let it equal to 0, and you solve x, you'll get x equals to 2. What is that? It's the turning point for the x value. That is what it gives you. So the stuff inside gives you the turning point, but not the minus 2. How will you find that turning point? You must take that stuff and it equals to 0. That's how I'll find my turning point, which if I want to write it in vertex form, I'll put it in there. If it's a positive 2, I must put it as a minus in that stuff there. Okay, so let me just put minus 3 again so you can see, right? Can you see that? That is the turning point. Now, x value is 3. So, but it goes 3 places to what direction? To the right. Can you see that? Because we have got a minus there. So that is why when we are using this particular axis of symmetry, I calculate the x directly here. This is what I did, all right? So if I take you to the original function, this function here, so if I take you to the black function, let's take away the other one. Can you see that you have got the x value, which is 1. That is the turning point, and y value is 4. That is why I have it here, 1, 4. But it's easy because if I know what the turning point of 1 is, by using this axis of symmetry formula here, if I write it in vertex form, it's going to be the opposite of that sign, or squared. Then I can find this particular value by taking that original x value, put it into the original function, and see what it gives you. That 4, if it's positive or negative, is the vertical, is the y, the q value in my particular formula there. That value says the up or down movement of the graph. Okay, so that 4 that you are seeing there in this particular case, I just have to write it back, and I put x minus 1, my original function. Okay, so I'll uncheck that one. So I'll be writing the formula y equals to negative 1, then it was x minus 1, okay, all squared, then it was plus 4. Can you see that if I didn't put anything, it's already at x there. It's at the x-axis where y is 0. There is no movement. There's no vertical movement. It's just at 0. no vertical movement. The moment I put plus 4, it jumps up from that 0 4 places. That is what it means, that 4 that you see there. If that 4 was like a negative number, so if it was like a minus 4, for example, if it's minus 4, the graph will go down 4 places in this y direction. So the important thing about this one here particularly, okay, this is plus 4. The important thing about this one is that it gives us, the Q value gives us the vertical translation up or down, 4 places up. Okay, the stuff inside gives you the horizontal translation. So if you take that stuff inside, let it equal to 0, that x value is the turning point, the axis of symmetry is the turning point, the x value. Okay, so if you get questions of that nature, I would say there are other ways that you can do it, and of course if you go to my channel you will see that, but you just use this formula here. That is the axis of symmetry. You get your x value, that is like your turning point. In your vertex form, it's going to be the opposite, the sign there, whatever it is. If it's a positive, it's a minus there. Don't forget the square. The minus a is the a value, which you can identify it right there. Okay, if it was a 5, you would put minus 5. If it was a positive 2, it would be 2 there. And the 4, you get it by taking the x value, put it back into the original function, and then you just write it in vertex form. Good. Let's come to question 25. So you have got functions. You have got function f, and they say find f of negative 3. That means in function f, you are going to put where you have x, you replace it with negative 3. So there's a value here. So this is nothing but 2 minus, this is 9. Okay, and if you do that, you get nothing but negative 7 as an answer. The same you do at g. The only difference is that at g, the function has got some letter. So you're going to say, okay, here, I'm going to replace that and that x with the g of x. Okay, that was 2 of x, rather. So I will be saying g of 2 of x is equal to 2 plus 3. So here, I'll replace it with 2 of x. This is already the final answer, but you can go ahead and simplify it. You can say it's 4x plus 3, but this is more than enough. Okay. Right, now you have to take function g, the whole function g, this one here. And because you go from the right to the left, and you put that whole function g into function f where you have an x value. That's what you do there, and you give it in simplest form. So that means I'm going to say f of g of x is equal to, what is function f? It is 2 minus, where you have that x value, you substitute function g in there. So function g was 2x plus 3. Now, it says you must simplify because it's not yet in its simplest form. Okay, that means you have to multiply out that bracket. So if you do that, you have 2 minus, here you will have 4x squared, because remember 2x plus 3 times 2x plus 3, 4x squared that I have here. Then I have 2x plus that, so that is 4x squared. 2x times 3, that's going to give you 6x. If I come here again, I get another 6x. Can you see that? And if I take 3 times 3, I get what? I get a 9. So I've got 6x plus 6x is 12x, or 12x, and plus 9. That is what I have done there. So I am not done, because there is that concept of the minus. If you were to continue with that and you remove the bracket, just bring in another color, you will see that I will have 2 minus 4x squared, this negative is going to change everything, minus 12x minus 9x, minus 9, rather. Okay, that is this negative times everything in there, everything in there, everything in there. Okay, so what do I have? I have minus 4x squared, I have minus 12x, but the numbers 2 minus 9, and 2 minus 9 is minus 7. And this is the answer. There you go. So you have simplified it. Okay, of course, you have to do a little bit of work there in order for you to find the solutions. All right. Very important that you are spacing for your work accordingly, so you do not work a little bit confusing on the confusing side. So I'm just going to draw little rectangles to show you my final solution. Now they say you must find the inverse of function g. Okay, the inverse of function g. So let's just write down what it was. G of x is equal to 2x. So g of x is equal to 2x plus 3. It obviously comes from here. So the inverse of that, you're obviously going to write here y equals to 2x plus 3. And then you will be swapping the letters. Okay. But this one you can also solve by inspection, because you should realize something, that here the 2 is being multiplied, so we expect it to be divided. Here the 3 is being added, so expect it to be subtracted. Okay, it's the inverse operation. Anyway, let's make x the subject of the formula. Okay, by switching the letters. So we're going to switch the letters. Where y is, we put x, and where x is, we put y. Objective is to make y the subject of the formula. Then 2y will be x minus 3 on this side, because that 3 goes to the other side. And if I have to continue, I am going to get something like my y equals to that x minus 3 over 2. But you cannot leave your answer in terms of y. Okay, you just borrowed that. You must now say, therefore, the inverse of that is equal to x minus 3 over 2. And that is the final answer. All right. There you go. Right. Anyway, as I was saying already, the 3 should be subtracted and the 2 was multiplied, so it needs to be divided. That's the inverse operation. Okay. Okay. Let's go to the next question. The next question being question 26. Question 26, they say in the diagram, D is represented by the point negative 3, 3. E is 3, negative 5. And F is negative 1, K. These 3 points are on a Cartesian plane, an xy plane. And you are supposed to find the length of DE. I put the formula down here for you. The length of a line segment, if you have 2 points, so we have got the points. So let's write the points we have. Okay, we have the point D. Our point D is negative 3, 3. So I'll put my point here. Negative 3, 3. And our point E is the point 3, negative 5. If you want to find the length of that, you will be saying the length of DE is going to be calculated by taking the x value, maybe the second one minus the first one. It doesn't matter. I'll take this E, so I will be taking the 3 in bracket minus negative 3. And I'll square that. Plus, now take, because I started with the 3 of E, I must start with the negative 5. Then I say minus 5 minus that other value of y and square that. All of this is going to be under the square root. Now you will get the same answer if you were to take the x value of D. You say negative 3 minus 3 and then 3 minus negative 5. It will give you the same output. So from here, simply a matter of putting the stuff on the calculator. So you have got 3 and negative. Then negative was going to give you obviously a positive value, minus 3. Okay, all of this squared plus, then you have in brackets again negative 5 minus 3, all of this squared, and you hit enter, you get 10. So the answer is what? 10 units. It's the length of that line segment, so we don't know if it's centimeters or whatever. The formula is right there. Then gradient of DE. Okay, the gradient, you take the one y value and subtract the other y value, and you take the other x value, subtract the other x value. So if I decide to find the gradient of DE, for example, I will start with D. I'll take the Y value, so maybe sometimes to avoid confusion, right here XY. Okay, so you can know, right here X comma Y. So I'll take the Y value of D, which is 3, minus the Y value of E, which is what? Negative 5. All of this I'm going to put over, okay? Because I started with the Y value of D, I must take the X value of D, which is also 3. And I'm going to minus with the X value, XY. So we just have to come back to something there. My goodness, we are here. I'm looking at the wrong place. So the X value here is negative 3 minus, okay, let's just go back, Mr. Max. The X, the Y, we are now busy with X value. X is negative 3 and 3. Good, negative 3 minus 3. The Y value, let's just check. It was 3 minus negative 5. Now, this on top is 8. This on top is minus 6. If you were to clean this up, which is already your answer, by the way, because you will already get a mark for that, but you can simplify it, and it simplifies nothing to negative 4 over 3, or anything equal to that. Okay, you can put it as a mixed number, and so on. That's how you find the gradient. Of course, you would get the same answer if you were now doubting. Like if a learner or a student was saying, now what if I was to do this and I was to take the gradient of ED? That means I start with my point E, okay? Rather than, now if you start with your point E, if you take the Y value of E, which is negative 5, okay, minus the Y value of D, which is 3, over the X value of E, which is 3, minus the X value of D, which is negative 3. On top, you get negative 8. Under, you get 6. These two are exactly identical. It doesn't matter where the minus is. The whole fraction is negative. It will give you the same answer. You get it? So, if you were doubting it, you can check your calculator, and then I can prove it with your calculator. So, you can say, okay, negative 8 over 6, whole thing, negative 4 over 3. If you were putting 8 divided by negative 6, the whole thing is negative. So the whole fraction is negative either way. Gives you the answer. All right. Now they are saying if k is equal to negative 8. So let me just go back to my diagram. So now they are saying k here is negative 8. So my f will be now negative 1, comma, negative 8. That is what now the coordinates of f will be. So now I come and they say determine the coordinates of M, the midpoint of DF. So D, we know the coordinates of D. The coordinates of D is negative 3, 3. And we know the coordinates of F. The coordinates of F now is negative 1, negative 8. Just making sure. Let's go back to our diagram. Negative 1, negative 8. Now, we want the midpoints. Now, in order for me to find the midpoint, I take the two x values and I add them. Okay, I will say midpoint equals to, the formula is right here also. The two x values, again, I always say to the students who are having trouble, always put x, y on top there so you do not make mistakes. Add the two x values, that's negative 3 plus negative 1. You divide that by 2, that will give you the x value. Add the two y values, that is 3 plus negative 8. You divide that answer by 2. This is going to give you the midpoint. Now, let's do the numerator. The numerator, this one is negative 2 over 2. And here, it's 3 minus 8 is negative 5 over 2. Right, these are practically the answers, but you can negative 3. In fact, a little bit of an error here. This answer is going to be negative 4. Negative 3 plus negative 1 is negative 4. So I get negative 2, this answer here, and here is negative 2.5. Okay, it's negative 2.5, negative 2.5, if you so wish to write it like that. That's it. And obviously go through and write this down. If you don't have it, how do you find the formula for the midpoint? How do you find the gradient of a line segment? And how do you find the length of a line segment? Okay. All right. Now let's come to question 27. It is given that in the figure, AD is equal to P, as you can see. AB is equal to 2Q, as you can see. Line DC, this whole line here, is parallel to line AB. Okay. And here comes the most important and straightforward concept. They are saying that line DC, okay, let's put a red color. Line DC is 1.5 times of whatever AB is. So what does that give me? That's 1.5 or 1.5 times AB is represented by 2Q. That's it. If you multiply that, that is going to give you what DC is, right? So DC is equal to 1.5 times what AB is, which is 2Q. That is 3/2 times 2Q. Okay. If I want to do that, I'll get nothing but 3Q. If you multiply the 2's, they cancel. Right. Then they say find BT. Now here's the thing. We are now told that point T is on the line BC such that BT to TC is 2:1. So if it's 2:1, the ratios consist of how many parts then? The parts is 3. So this one occupies 2 out of the 3, that is this one, and this one occupies 1/3. That's what it is. Okay? Right. Another thing. So if you can now determine that we can say that BT, right, and I'll write it in here, BT is equal to 2/3 of BC. Whatever BC is, BT will only be 2/3 of that. But how will I find BC in terms of my Q and my P's? I will say, and I'll write it inside here, I'll say that BC, think of it as a traveling way. How do you go from B to C? I go BA plus AD plus DC. This will give me BC, so that I can put my BC here on the 2/3 here. So this is going to be how I find my BC. So let's write it down using our P's and Q. And also, please take note of the direction that we are going. All right. Taking into account that if you look at going from B to A, you are going against that. You see that arrow is pointing to this direction, but now you are going against it. So you are going minus 2Q. So BA is minus 2Q. And I'll write it here because I want to work on the diagram. So that's minus 2Q. Okay. AD. Now if you look at AD, you are going along that vector P. So it's not against it, you are going with it. So it's plus P. So that's AD, it's plus P. And what is DC? We already determined what DC is from our part in A. Our DC is 3Q. So we'll just write 3Q. So this will give me BC. And I'll just write it down so that you can see. Okay, in this space. So BC was given to me as minus 2Q that I've calculated, plus P plus 3Q. Okay, which gives me 3Q minus 2Q gives you positive. So it's the same as P plus Q. That is what BC is equal to. But we are looking for what? BT. T. And from what I wrote down, I said that BT is equal to 2/3, remember, of whatever BC would be. So that implies it's 2/3 of P plus Q. And that's it. Nothing that you have to do further. You don't have to multiply that 2/3 out. You can leave it like that, vector geometry. So you have to work on the diagram. You have to think of it as a direction. How do you go from B? How do you go from B, okay, to C? To go from B to C is you're going here, this way. You are going against that. That is why I have a negative. Then you're going along this, that is plus Q, plus P. That's why you have that. And then you go all the way in this direction. That's the same direction of travel as you get. That is how you can find BC. Because we cannot go directly to BC because we don't have Q's and P's there. So how else are we going to find it? We're going along that. Write that into like that and simplify it, and that's how you get the answers to that question. So as you've seen in all these questions, I'm working on the diagrams, and I will encourage you to do the same. Right. Now, I'll make this one a little bit smaller. They say describe the transformation that maps A onto B. Now you can see that the two shapes have exactly the same, the shape didn't change. It was not enlarged, it was not smaller, it was not rotated. So this is translation. Translation is the sliding movement of a figure. Slides. So this is translation. Please, it is not translocation. It's translation. That's what happened there. That's one mark. We explain this by a vector. A vector gives you the x direction, gives you the y direction. If you look at A and if you look at the direction of x, let's take this particular point here and compare that point with this point in the x direction. X direction means to the left, to the right. And make sure that you understand your units there. You will see that it's 1, 2, 3. It goes to the left. So when it goes to the left, the x direction to the left, it means you have a negative value. So in my vector, I will be writing -3. Then let's take the same point and we compare it in the y direction. Upwards, it goes up. Since the corresponding point from A to B goes up, that is 1, 2, 3, 4, 5. Okay, upwards. If it goes up, it's positive. Had it gone down, it was negative. So +5 there. So here you put 5. You have now described that particular transformation. Single one. It's only a translation. It cannot be a translation and a rotation. It is only a single translation. That is why it is bolded in effect. Now they say, reflect triangle A in the line x equals to 0. And here is the most important thing that you must know. The line x equals to 0, wherever x is 0, it will always be on the y-axis. On the y-axis, any point on the y-axis, x will always equal to 0. So this is the same as the y-axis. So that is our line of symmetry. So we reflect this, we'll say triangle A. This is our mirror line. So if I was to reflect this, this is the mirror line. Every point should be exactly the same distance from this mirror line. So it's 2 units there, so I'll go 2 units across like this. This one, if you count 1, 2, 3, 4, so it has to be 1, 2, 3, 4. That corresponding point will be there. Then it becomes easier for you to locate the other one. Okay, you have reflected it like that. So it's just a matter of joining them. Joining it, and then you have it. Right, and then it says label it, and you're supposed to label it what? Label it C for 1 mark. And you label, say, okay, this is C. That's it. Correct reflection. Halfway between, okay, the y-axis. Right. Then enlarge triangle A with a scale factor of 1/2. When you enlarged, and they're giving you the center through the origin, Origin is the center. So my center is the origin 0, 0. This is my center. It's here, the origin. Now here's the thing. Whenever the scale factor is a half, the image that we have to do, number one, the image, the one that we have to do, will be smaller. Okay? So it will be smaller than what A is. It will be actually half of that. Right. So if I have to draw that, this is 2, it will become 1. That is 2, it will become 1. So I'll have a little triangle that is half of this one. Then what is the next thing to remember? The image, the one that we draw, okay, because that one, the A is the object. The image will be closer to the center, to the center of enlargement. It will be closer. So what does it mean? The image, okay, to explain this nicely, the image cannot be away from the center. It cannot be away. It has to be closer. Okay, it has to be closer there. So how will I draw that? Of course, I would suggest you take your ruler and you draw yourselves lines like so. Okay, you take it again this side, you draw lines like so. And you can bring in the third one if you want to, but I can already see where my triangle will be. And from what I see is that I can see my triangle will be here, closer to the center. It will be here. That is 1, because this one is 2, so that one must be half. Okay, just my drawing is a little bit crooked, but you get the idea. Let me just make it go nicely. Let's just go back. So it will go from there all the way here, from here all the way there, from here all the way there. Right. Now, what if you say, but Mr. Max, I will not be able to do that and find that. Okay. How will I find my where it's going to be? If you take the points of A, and I'm going to write down the coordinate points of A for you. And let's write it down in blue. This point here is the point -4, comma -4. Are we together? Because it's half, just take half of that point. What will half be? Half would be, half of that will be -2, comma -2, which is this point here. Okay? Another one. What is this point here? Say, okay, Mr. Max, this particular point is -4, comma -2. Then you have to ask you, what is half of that? You say, okay, half will be -2, which is there, comma -1. -1 is here. And I'll leave this one for you to find. Okay? Then once you have the points, right? Then you plot the points and you draw that. It's as simple as that. So you are supposed to label it D. So my coordinate points will be -2, 1, comma -1, rather. It will be -2, comma -2. Okay? -2, comma -2. And the other one that I was now saying, it will be -1, comma -2. Okay, they are all in the third quadrant. Everything is negative. Plotting those points, then you draw it, and then you have it. Okay, don't spend too much time on that. Good. Now I have done it also here so that you can see how it looks on the software. Okay. Very important, so I'll just leave it there so you can see. And the information that I was just writing, when I say large triangle A with a scale factor of a half through the origin, I wrote it down for you. The image will be smaller, as you can see in D. Another thing, the image will be closer to the center of enlargement, and the center here was the origin. It cannot be at the other side, for example, of the image. It has to be closer to that. Okay, that's what you do. Good. That brings me to question 29. Dan either walks or cycles to school. The probability that he cycles is a third, as you can see in the diagram. When Dan cycles to school, let's just focus on the cycling part. The probability that he is late is 3, when he cycles to school, the probability that he is late is 1 over 8, as you can see. When he walks to school, the probability that he is late is 3/8. You have to complete the diagram. You get an independent mark for any correct 2. How many are you supposed to? 1 mark for any correct 2 branches. Okay. When you come across like this, it should always add up to 1. 1 over 8 plus something should give you 1. So that's 1 over 8. You need 7 over 8 here to complete it. How will I know? Because I said 1 over 8 plus 7 over 8 should give you 1. So how do I find the 7 over 8? I say 1 minus 1 over 8, and that is how I know I get 7 over 8. But you can just look at the numerators, okay? Again, the same, because this is supposed to equal to, okay, my goodness. Let's change the color. This here. Right, I'll just write it down. This thing I was trying to play around. This here should add up to 1. This here should add up to 1. The same like this here should add up to 1. If that is 1 over 3, this must be 2 over 3. Okay, how do you find it? You can say, wait a minute, take my calculator. If you were not sure, you say 1 minus 1 over 3. Okay, it's 2 over 3. And I said, just look at the numerators. That is 1 to give you over 3, so 2 over 3 will give you 3 over 3, which is 1. So guess what this answer will be? That is 3 over 8. This one will be, guess it correctly, it's 5 over 8. Or you can look at your calculator, you say, okay, 1 minus 3 over 8, and I have got 5 over 8. Avoid working with decimals now, okay? It will just make your work a bit easier, but it's not going to be wrong. You get B1, 1 mark for any 2 correct branches, okay? 2 correct branches, right? So that's how you are going to be given a mark there. Calculate the probability that Dan cycles to school and is late. So cycles to school is 1/3, okay? And late is 1 over 8. So you multiply. When you're going along the branches, you multiply. Whatever that answer is our final answer. 1 times 1 is 1. And 3 times 8 is 24. And that's the answer. Then they say, calculate the probability that Dan is not late. Now, if he's not late, it means he's late. If he's not late, then it means he's late. So let us see, that means he can be either late, but he's not late. Hope you're not confused. So probability that he's not late. Not late would be cycle, not late. So we go 1 over 3 times 7 over 8. Let me just write that one down for now. Okay, 1 over 3 times 7 over 8. But that's not the only one. When he walks, 2 over 3, that's the one, 2 over 3. You must multiply. You go along the branches and multiply. Not late again, remember, not late. 2 over 3, not late, 5 over 8 times 5 over 8. All this will give you the final answer. When you multiply this one, you get 7 over 24 plus. When you get this one, 2 times 5 is 10 over 24. 10 over 24 is the same as 5 over 12. You can use your calculator for all of this, right? The final answer, okay, is going to be, let me not simplify it. Let me just leave it as that. So 2 times 5 is 10 and 3 times 8 is 24. Adding numerators gives you 17 over 24. Of course, there are other ways you can do this one. I will maybe introduce or include let me include a page there so that I can see. Right. There is a way to say, let's suppose we look at the times that he's late, because this one is not late. Okay. So we are going to look at where he's late when he cycles. We're going to look at when he's late when he walks. Or the other way around, I could have written cycle first and then late. Okay? Cycle and then late, walk and then late. So just have it in the same order so that we are sticking to the way it is given. So we say, let's find when he cycles and he's late, when he walks and he's late. Let's go back to our diagram. What is the probability of cycling? Cycling is 1 over 3. And what is it when he's late? When he's late, 1 over 3 times 1 over 8. So cycle and late, 1 over 3 times 1 over 8. I'll write it down. 1 over 3 times 1 over 8. There's also walking, so I have to go to walking again. Okay, want to find late. Walking is 2/3, remember? So it's 2/3 times late. 2/3 times 3 over 8. 2 over 3 times 3 over 8. Okay, 2 over 3 times 3 over 8. Let's grab our calculator. In fact, if you were to calculate using your calculator here, you are going to find that this answer, let's rather bring in calculator so you can be sure. Okay, I can obviously calculate it, but let's just work so that you can also follow. Times 1 over 8, okay, plus, again go 2 over 3 times 3 over 8. 8 equal to, give you 7 over 24. Now, this is late. He's late. He's late. Okay. We don't want late. We want not late. So, in order for you to find not late, you will say 1 minus when he's late. 1 is the same as everything now considered 24 over 24. Okay. It's that thing. You must make sure when you say 1 minus, you're going to get the same answer. You're going to say, okay, let's see. 1 minus 7 over 24. 17 over 24, which was our answer that we got. That part, 17 over 24. Okay? Different ways to arrive at the same answer for 3 marks. A little bit of work, but I think you will agree with me. You can use this one where it's you go to the branches and you find not late plus not late, and then you get directly to your answer. Or you find late and subtract it from 1. Okay. All right, let's go to the next question. There is a part C. There are 198 days in a school year, so 198. Work out the expected number of days that then cycles to school in a school year. Okay, what is the fraction that he cycles? The cycle fraction is a third. So you simply say a third times that. So it's 1 over 3 times 198. Okay, that's the only way that you can get that. Of course, when you calculate that answer is 66. And you'll be saying 66 days for 1 mark. Right. Question 30. Okay. I'm going to give you a little bit of a breather for you to write it down. Okay. Before I explain question 30. Right. Question 30. Abed did a survey about the amount A of money spent by 120 men during their summer holidays in Britain. The accumulator frequency table gives some information about the amount of money spent by 120 men. Complete the frequency table below. Right. If you look at the frequency table, of course I have it here, but I want you to focus because I'm going to show you how to do it. If you have to look at the difference between these two, those people who spend less than 0 didn't spend anything. There's nothing. The people who spend less than 100 is 13. But the people who spend less than 150 are now 25. People who spend less than 200, and this is where I want to come in. This 200 here, the people who spend less than 200 are 42. Okay. And the people who spend less than 250 and so on. That's what it tells you. People who spend less than 400, 120. Okay. All of them. Now, if you add up the stuff from 0 to 100, from 0 to 100, you see it's 13. From 100 to 150, people who spend between 100 and 150, that's 100 and 150 here. That will be 25 plus 13. Okay? From 100, not plus. The people who spend between 100 and 150, for you to find that, you have to do a little bit of subtraction. The people who spend here, you say 25 minus 13. That is where the 12 comes in that you see there. Okay? The people who spend between 150 and 200, people who spend between 150 and 200, that will be 42 minus 25. And that 42 minus 25 is where you get the 17. The people who spend between 200 and 250, the people who spend between 200 here and 250 will be 64, take away 42. Okay? If you do that, you get 22. That's where the 22 is coming. The people who spend between 250 and 300, between 250 and 300 will be 93 minus 64. Okay? 93 minus 64, that is 29. That is where the 29 is coming from. 29 is coming from. And you can complete the rest and you will see that the answers will be 17 and 10 respectively. Okay, that's how I have the table over there with solution. How do they mark this? They give you one independent mark for 2 correct. So if you have 2 correct, it's 1, 2, 3, 4, 5, 6. So it's 3 marks. If you get all of them correct, it's 3 marks. But if you only have 2 correct, any 2, then you get 1 independent mark for that. Right. This frequency table is very important. We're going to use it again on a later part. On the grid, draw a cumulative frequency diagram. So I brought that table, the cumulative frequency table, this one. I brought it here and I put it next to, because that is the table that we're going to use to draw this graph. Cumulative frequency is the sum of all the previous frequencies up to 120. So how do you get that? From 0 to 100 is 13. But from 0 to 150, people who have less than 150 will be obviously 13 plus 25. If you add 13 plus 25, if you go, how do you find people less than 200? Less than 200 will be everybody here. 25 plus 13. You add them up, 13 plus 25 plus 42 plus 64 plus 93 plus 110 and so on. Give you that. Maybe I should clarify it more clearer. People who spend less than 100 are 13. But now the people who spend less than 150, okay, less than 150 in that column, they are 25. 25. How do you get that 25? Remember, if you go to this one that we calculated, and if you had to add, if you have to add the frequencies together, okay, let me just make sure that I can bring that nicely for you. I think that concept I will use it in the next part. Here, the most important thing that I want you to remember is that if you use that frequency table that you have, the ones that are summing up to 120. So if I take my calculator and I show you what I'm trying to say, if you add those frequencies, 13, because I'm not going to put 0, plus 25, plus 42, plus 64, plus 93, plus 110. Okay, it's not the way I'm looking for it. They should add up to 120. The ones that add up to 120 is obviously this one. If I go to the frequency table, if you add 13 plus 12 plus 17 plus 22 plus 29 plus 17 plus 10. When you are adding those accumulation, should add up to 120. It's one way that you can always check how to do that one. That is what I meant by that. But when you are plotting the cumulative frequency, that graph, which is an ogive or cumulative frequency curve, that curve you use the cumulative frequency table that was given in this case. Now, you have to be able to determine what does each little block represent on each of the axes. If you look at the y-axis, from 0 to 10, you have got 5 blocks. So that means 10 divided by 5 equals to 2. So each little block represents 2 units on the y-axis. If we come to the x-axis, you have got 50. 5 into that. So that is like 50 divided by 5. So each block represents 10. Now, if a is 0, that is also 0. So it means we are starting from the origin. We are starting here. I plot that point. If it's 100, okay, if it's 100, it's giving me 13. Now 100, 10 is there, 12 will be there because this block is 2, 13 will be in the middle, more or less. If it's 150, it's 25. 150 will be what? 20 is there, 22, 24, 25 is in the middle. If it's 200, it's 42. 200, 40 is there, and 42 will be over there. If it's 250, it's 64. 250, I go all the way up to 60, 62, 64 will be over there. If it's 300, it's 93. 300, 90 is over here. 92, 93 is halfway in the middle there. If it's 350, 350 is 110. 350, 110. Okay, it will be right there where I am. If it's 120, it's going to be, if it's 400 rather, it's 120. 400, 120. 400, 120. So your curve should not pass this point. So now that you have plotted it, you have plotted all the points because you get a mark for plotting. Okay, and I will show you how we mark it later on. Now we have to draw it. Please, it's a curve. Okay, so we'll draw it, a curve, but make sure the curve is smooth because you will be using it to solve some questions. I'm trying because I'm trying to concentrate. Okay, let's finish the rest. Always have to visualize something before you just draw it. Visualize it. it out there, but perfecto. There we go. Okay, some students were using straight lines. I will show you how it was marked. By any case, that's what we're looking for. Now they say use your cumulative frequency, yours, to estimate the median. It's an estimate because not all of our curves will be identical. How do you find the median? You take half of the total frequencies. So what is half of the frequency, which is 120? It's 60. That means I'll go to 60 on my graph. Okay, maybe I will use this. Let me use the red. I'll go to 60 here. And then I'll write down and read down what it reads. Now, if you look at my graph, remember each block here is 10 units. So that's 200 to 10 to 20 to 30 to 40. I get 240. Yeah. So I move in the range here. My answer that I get 240. But because it was an estimate in the exam, any range from 235 to 245, depending on your curve, will be given a mark. But if you're outside of that range, you're not going to get it. How do you find the median? You take half of the total frequencies and then you write it down because we are looking for the dollar, for the pounds. So you have to do that. The interquartile range. Now the interquartile range is you take the upper quartile, which is 3/3 of the total frequency, minus the lower quartile, which is 1/4 of the total frequency, and you subtract them together. Now, let us see what is 3/4 of 120, and let us see what is 1/4 of 120. Okay, so this 3/4 will be 90. 1/4 will be 30. So what does it mean? I have to go now back to my graph and find 90, do the same, and see where I land. Okay, so let's go to 90. And if I look at my 90 using this 90 all the way here, if I have, because it's just an estimate, I'll have something here. Yeah. It's somewhere there. There. That is 90, and I read 250 to 60 to 70 to 80 to 90. And you see I get 290, and I get 290. So my upper quartile range, and I'll write here Q3, I got 290. So any range between 290 and 300, you get the mark. Okay. My lower quartile range, I'll have to go to 1/4. What that 30? I'll go to 30. So I'll do the same. You obviously use a ruler in the exam, 30 over there. And I'll write down what I have here. That is 160. Can you see that I have 160? Okay. And if you have anything between 160 to 170, you get a mark. So mine here was 160. 160. Now, how do I find this answer? You subtract the two from each other. So the interquartile range will be 290, take away 160. Okay. And if you do that, that's 290 minus 160, of course, 130. So my answer was 130. So anything between 125 and 135 would be accepted. My answer was obviously 130. This is a very smooth curve. So your curve should be a bit smooth here. So let's see what happens in the exam. The curve must not go beyond this point. You get 2 marks for the points, 2 for plotting. You get 2 marks. All the points, if you plot all the points correctly, like this one's in red, you can see these points that I have plotted. All of them, if you plot them correctly, you get 2 marks. And then you get 1 mark for, if you plot between 4 to 7 points correctly, then you just get 1 mark. You get C1 for the curve, 1 mark for the curve. And here they accept if it was ruled, if you use a straight line, but it's a curve, okay? Because I gave you the definition here. If you draw a cumulative frequency distribution using the data recorded in the cumulative frequency table, like the one below that I've indicated, we obtain a smooth curve. There's an E missing there. A smooth curve, okay? That smooth curve is called a cumulative frequency curve or an ogive. This is an ogive. This is from French, okay? But ogive, that's what it's called. Very important, that information. All right, let's go to question 31, which is the last question in this question paper. You have a histogram, and please always take note that you're going to get histograms, and statistics is quite important. You always get it. Now, if you look at that, you have all the frequency density over there, and we have got a table. And the histogram shows the height of the plants as measured during an experiment. You are supposed to complete the frequency table. Now, in order for you to do that, you need to know how to find the frequency density. But if you don't know to find the frequency table, you can ask yourself a bunch of questions. How did they get the 20 over here? They got this 20 and the 40. Look at the intervals from 0 to 5, which is this one here, and they get 20. If you look at this rectangle and you calculate the area of the rectangle, if you calculate the area of the rectangle, that is 4 times 5. When you calculate the area of the rectangle, you get 20. That's what they did there. Let's see how to find the one between 5 and 10. What is the area? It's 5 units over here, because here it's 5. The area of the rectangle. And it goes all the way up to 8. So the area of this rectangle, maybe I must write it inside, then it's much easier. So write it inside with red. Here it was 2 times 4, times 5 rather. 2 times 5. That's how it's, my goodness, it's 4 times 5. It's 4 times 5. That's how we get to 20. This one here will be same as 5 again, or I can say 5 times 8. 5 times 8 is 40. This one here is again 5 times, let's see, what is the height of that? 14. 5 times 14, well, that gives you 70. This one here, if you count, that is 5. 25, take away that, that's 10. It's 5, it's 10. This is 10 times, what is the height? Times 12, that's 120. This one here is, if you now take 50 minus 25, or you get this 5, 10, 15, 20, 25. So it's 25. What is the height? Times 4, well, that's 100. And then you just go ahead and fill in the values. So the missing value here was 70. The missing value here was 120. And the missing value in the last one is obviously 100. Now, what if you did not use your table? Okay, if you know the frequency density formula is frequency density is equal to frequency divided by the class width. So you cross multiply to find the frequency alone, it's the class width times the frequency. So if I have to find the frequency density, and I'll write it from diagram. For the frequency density for this class here, from the diagram I see, I'll write FD for frequency density. From 0 to 5, the frequency density is 4. From 5 to 10, the frequency density is 8. From 10 to 15, the frequency density is 14. Just write them down. Okay. From 15 to 25, the frequency density is 12. Write it here. From 25 to 50, the frequency density is 4. So now I know what my frequency density is. Okay, I know what my frequency density is. I simply just look at the diagram. My class width, I can now maybe write class width here. What is the class width here? 0 to 5, it's 5. What is the class here? From 5 to 10, 10 minus 5 is 5. What is the class width here? 15 minus 10, well, it's 5. You can see those bars are exactly the same width, those three. What is the frequency density here? Well, if you say 25 minus 15, well, that is 10. And what is the frequency width here? 50 minus 25, well, that is 25. Good. Now, how do you find frequency? You multiply the frequency density times the class width. All right. So if we had to take the first one would be the first one here. So maybe I will say bring in letters. So if this is A, that is B, C, D, E. The frequency for A would be, the frequency density, which is 4. What is the class width? Times 5. 20. It's already done for us. For B, the frequency density was, so you will know how to find the answer for B. So B would be saying frequency equals to frequency density, which is 8 from the diagram, times the class width, which is 5. That's how you get your 40. How do we find C? C, the frequency density, or the frequency would be the frequency density of 14 times the class width, which is 5, times 5. Goodness. 14 times 5, 70. D, frequency equals to frequency density, 12 from the graph. What is the class width? 10. 12 times 10 is 120. Got it there. Okay. What is the one for E? The frequency would be calculated by saying the frequency density, which is 4 from the graph, times the width, or the class width is 25. That is 100. And this is how we find those 3 marks for you, because it's 1 mark for each. Right. This is quite a long paper, okay, and I tried my level best to also explain and give you more input and so on, so you can know how to address the question and also what to expect in the examination. Right. I would suggest that if you do have a copy of the question paper, that maybe you work out the question paper also before you just look and attempt to solve, look at my video. And good luck with your studies, because it can be very helpful in the long run.